Greetings of the day, listeners. I am Aarti Devraj, working as Assistant Professor in Kartham College of Engineering. So, now I would like to give a brief introduction towards what is a data structure. So, data structure, as the name implies, it involves some structuring of data, structuring in the sense arranging or organizing or even ordering the given data in some particular order. So you can take an example like you can find your contacts, right? So that has been arranged either in alphabetical order or by alphabetically arranging the numbers. So a good example could be you can find it in your WhatsApp, right? So when you're just having a group and you're opening it, maybe you haven't saved most of the numbers. So all those numbers will be present in alphabetical order. This is a kind of organizing your data, right? So we'll see what happens when your content is organized or that is present in random manner. So how data structures are used in doing that work. Okay, so first will be why data structures. So as I have already told an example, you can just take the same example when you're trying to search in contacts for some person's contact. Okay, so either your contacts will be present in sorted order or it may be present in some shuffled order, like recently added first or the recently added the last, or with the help of ordering by phone numbers, right? So there may be any order that your contacts will be present in any of the orders. And when you're trying to search for a contact, obviously the preferred way will be when your contact is present in sorted order, either with the help of numbers or any other field with the help of alphabetical ordering, or any other field when it is in arranged order. Maybe organized order will help you to search easier, right? So why we need an order for making it easier to access? So that is what is the next question. So when we are technically speaking, so when it is a general one, you can see like you have contacts, you are just searching for one. If it is in alphabetical order, okay, if you just somewhere press in the middle of your ordering, maybe that will move to mth letter or nth letter, right? So you can directly check for the nth name. So that is a very easier one. So technically, when you just think of it, what will be the use when your data is present in ordered manner? So that is a very simple answer. If your data is present in some ordered manner, so that will be very easier for you to access or traverse. So easier in the sense, what does the main theme is? The time taken for accessing the given data will be very much lesser. Easier fetching of your data happens. So this is what is the main theme behind data structures. So you can just justify like when your data is present in some sorted orders or in some sequential or arranged order, so we will find it very easier to access. That is, the time taken for fetching some data will be very much lesser. So now we'll move towards the types of data structures we have already, so which are very much helpful in reducing the time taken. So the first major types of data structures are, one is linear data structure, you can see it in the, let's say in the second one is non-linear data structure towards the right. So as the name implies, the first thing you have to think is the name, the word used for defining that particular name. So one is linear. So linear in the sense that is continuous or sequential, right? So as the name implies, linear data structure helps you to check for the elements sequentially, that is one by one in a continuous manner, right? So non-linear in the sense, elements may or may not be accessed in sequential order. It cannot be like may or may not be elements will not be accessed in sequential order, right? So that is what is non-linear. So you can see an example here. So the first linear data structure consists of 5 elements. So you can just consider this to be a kind of array, right? So an array, you can just have this representation to be array, which is an example of linear data structure. So as we all know, you will start with the 0th index, you will move towards the next index in a sequential manner if you're just accessing some value present in the array. Coming to nonlinear data structures, you can find I have 5 values A, B, C, E and F. So what are these values are? So consider these all blue circles as nodes, and those values present inside are node values, and the lines are used for connecting these nodes. As of now, know the terms. Nonlinear data structure consists of nodes and connecting lines called as edges. These will be explained in the upcoming videos or the lectures or slides. Okay, now so what are the linear data structures available are, as we have already discussed. So this is a continuous way of accessing, right? So which means your arrays, which the basic one we have seen till date, maybe that will be the first example for linear data structures. The next comes stacks and queues, and followed by linked list. So non-linear in the sense you have the two main types, one is trees, the other one is graph. So these are the basic data structures available, and now we'll see some real-time examples which will help you to remember these types of data structure easily. We'll see some examples for all those kind. First we'll take stack. So this stack is a word which you might have come across in your lifetime for a longer frequently, right? So maybe it can be stack of books, stack of chairs, or you can say these are stack of discs, right? So the next one could be this, what you can call it as stack of balls present inside a bottle. The next one, scoop of ice creams, right? So what is the concept, what is the basic common concept all these examples have is a stack. So what could be a stack? So what is a stack is, you can see these examples. Maybe you take this ice cream scoops, so you have a purple color present, after that you have a blue, and then maybe an orange shade, and a dark somewhat a brownish shade, and then you have a cone, right? So now when you try to eat this particular ice cream, the first scoop you should eat will be the topmost present scoop, right? That is the purple color one, and then followed by the blue, orange and brown. So this is what is the way you will eat your content. So but when you just think of the preparation part, you will have the cone first, the brown scoop will be placed, and after that the orange scoop, after that the blue scoop, and then your purple scoop, right? So you can just imagine it virtually. You start with the cone, and preparation is the scoop of content is kept on one on the another. When you are trying to eat it, the topmost, the last kept scoop will be the first one to be eaten, right? Take the discs for a discs example. You have these discs present, and you can see the a red color circled disc present, and that will be the first one to be removed, followed by the topmost present disc, right? But when you're just trying to place these discs in order, so what might have happened is the flooring disc, that is the first one, the last present balancing disc, and followed by the orange, blue, green, yellow and orange, and finally the circled red color disc, right? So when with the help of these examples, you can just explain like the last arranged one is the first one to be taken out, or the first arranged one is the last one to be taken out, right? So this is what a stack data structures, that is, this is like the first in last out scenario, or last inserted element is taken out first, that is last in first out scenario. So you can see some other technical examples like when you have this undo option in your Word document or whatever it is, maybe an Excel or presentation or whatever MS Office package or WPS Office package, wherever you have this undo option, so that comes under stack data structures. So undo is mainly used for removing the last done operation, right? So the last element or last object, you have it in your maybe a document or the data, so that has the one to be removed when you have this undo operation. So when you have redo operation, obviously last deleted content will be done again. So whenever you are just trying to access the last done operation or last element pressing, so that comes under stack data structures. So in stack data structure, the insertion and deletion, they have technical terms. So one is called as push, which is insertion. The other one is pop, which holds for deletion. Okay, so when you try to push an element, that means you are trying to insert an element into top of your stack. When you are trying to pop an element, you are trying to delete the topmost element present in your stack. So next is a queue. So queue, this is most frequently used term. You can just take an example like you are trying to take books from library. So obviously if you have more number of person just trying to enter the data in your computer for books and taking it in your account, maybe you'll have a queue. So what happens is many people will be standing one after the another and trying to clear their bills or books, right? So you can see this particular picture. So we have an accountant or some receptionist, so who is trying to just enter all the details of your books, right? So a lady with some 3-4 books are standing in front of your queue, and a boy with some one book is standing at rear is end of your queue. Okay, rear is another explanation or a definition for end. Okay, another meaning for end. So end of your queue. So when this particular lady completes her work, so she'll be going out of the queue, right? So technically you can say it like you're removing her from your queue. So the next person will be the one who's reading a book, right? So likewise each person at front of your queue will be removed one by one once his job is over. And whenever you have to get added into your queue, you'll just come and stand or add at rear of your queue. At end of your queue, you just can get added to the present queue. So this is what is a basic a real-time example of queue. Technically speaking, in insertion or adding is called as enqueue, and getting out of the queue or removing from the queue is called as dequeue operation. Okay, so all these more technical values we'll just discuss in the upcoming or the future video lectures. So the next is a linker list. So you can see the name, right? Link list. So linking means you should have some chains for linking, right? Or some knots or ropes for linking your content. So you can just have or you can just imagine a type of train. So train which has more number of compartments. All these compartments are linked with the help of chains or tough ropes or whatever it is, tough or heavier chains, right? So now just consider this example. What your compartment will consist of is, your compartment will consist of some people, right? So consider these people to be your data or information content. Okay, so compartment will consist of data. So that compartment is linked to another compartment with the help of chains. So as we consider here, the compartments consist of content, and these different types of compartments are linked with the help of chains. You can see the green lines, right? So just think of the initial state of these compartments. So before arranging them as a train, these compartments were present somewhere, they were placed somewhere in the stations, right? So each compartment is taken and kept in order, and one compartment has been linked with the other compartment with the help of chains, right? So just technically think of these compartments or data field, data content, so which can be called as a node. So each compartment in a linked list will be called as a node. In all these nodes will contain one or more number of data, and these nodes are being connected with the help of links. Okay, so this is what is the concept behind linked list. Next comes tree data structures. So tree is a very common term, right? So you can just see this particular example. So this is some hierarchical way of arranging your content, right? So what is this is, you can just take a good example like your mobile phones directories, or your system laptops directories arrangement. So you'll have the main directory, say my files or file manager, right? So when you click on that, you'll have two more directories like internal storage and external storage, and inside that you can have inside internal storage we'll have photos, videos, and application storage like WhatsApp. Inside WhatsApp we'll have media, documents, stickers, images, all those stuff, right? So this is how a hierarchical structure will look like. Okay, so you'll have a main folder, and within that you'll have two or more subfolders, and from that you'll have another set of subfolders, right? So these arrangements you can just remember for a tree data structure. Okay, so where this random accessing comes into role is, you can see the main folder, right? So inside that you have internal or external storage. Maybe one time when you're trying to access the data, maybe you'll be trying to go into the internal storage. So sometimes you'll just move to the external storage. Maybe inside external storage you'll have n number of folders present, and you need not access the first folder or second folder each time to access some other folder present at the end. So if you have to access the last folder present, you can directly scroll all those folders and move to the last folder and access the data present, right? So this is what is called as random accessing, randomly clicking the folders whichever you want at that particular time. So next we'll see an example for graph data structure. So graph, in the sense, what should come into your mind as maps, right? So maps are the best example for graphs. So how you can connect this graph to your graph data structures? So as we have already discussed in your linked list or trees, we have nodes and links, right? So like trees and linked list, even graphs has nodes and links. You can just consider all the places present in the graph, or all the locations present in the graph, to be nodes. Okay, so the pathway connecting each and every location can be taken as your linking connections, which is edges. Okay, so you can see an example like they have just marked the places, right? The green circles, those are the places or locations, so which you can consider to be nodes, and the red lines which are connecting these points or maybe edges or links. So next, this is another simple example for graph. Can you just imagine what this is trying to say? So maybe a kind of social networking example, right? So you just see a lady with loudspeaker, so maybe an announcement, and a picture, and anime with some to-do lists. So these are some connections you have in your maybe social media, like notifications, mutual friends notification, their posts, everything can be viewed, right? Your colleagues post, and who have liked your colleagues post, all these stuff. You can just think like everything has been connected virtually, right? In the background they have been connected. So these are some examples for graph data structures, and I think this might have given you a good basic idea about what a data structure could be and how that could be in real life. So maybe in the upcoming lectures I'll just try to give some other basic knowledge about each data structure present. Thank you for listening. Happy learning, listeners.